So let us start. So let us start. In the last class, I have given some introduction on bolted joint. Now I will discuss how many types of bolted joints are there. Now, first of all, and these things are very preliminary things and you already know it. That is common bolts, screws and nuts you have drawn in your drawing class also. This is a two bolt. You see, this is a two bolt. That means on one side there is bolt head, on another side there is nut, and there is washer in between the plate and nut, and there are different type of washers, there are different types of nuts that I will discuss, but for the time being it is a two bolt and there is clearance. You see there is clearance. So when there is clearance, then the thing is can you get presentation now?
Yes, sir.
Okay. So on the right hand side at the bottom, this is the square head bolt. These are all very preliminary things. Now start and just differentiate between this tab bolt and stud. This one is stud, and for this stud you see both sides of the sorry, it is stud, it is not bolt. Now this is plate 1 and this is plate 2. There is a hole. The hole is not through hole. And
স্যার বুঝবো
শুনতে পাচ্ছ?
স্যার শুনতে পাচ্ছি
So drill is up to this point. Up to this point it is drill, and there is tap. So there is internal thread here, and both sides of this cylindrical element is threaded. Both sides are threaded. On that side there is nut. Okay, and this is the shape of the nut. Start. This is the shape of the nut. That means on both sides there are threads. Now there are some other common bolts and nuts, and you have already uh, drawn all these things. And there is one interesting part you see, that is how the threads are cut. You see threads are cut from this side and it is ended here. Okay, now for this threads are cut starting from here and it is ended here. This is the uh, this is the higher diameter end. This is the higher diameter end, and you see here this is higher diameter. There is a undercut, shoulder type of undercut is there, and you see the thread is cut over there. That means when you so the interesting part what I was trying to show you, that means thread cutting starts from this end, and since there is undercut, So thread running of the cart of the thread is ended here. So it needs no control for cutting of the thread. Here you need some control. That means you have to end here or you have to end here. But when there is some undercut like this, then you need not impose any control while cutting the thread. This is my point. And here also you see there is some undercut like this. There is some under for internal thread. There is some undercut like this. That means a higher diameter end, a higher diameter hole is there. That means when you start the tapping for cutting the internal hole, then it will end here because there is higher diameter part. And here there is no higher diameter part, so you should impose some control while running the tap for cutting internal thread. Is it clear? Huh?
Yes, sir. Yes, sir.
So these are very basic things. Now the washer, these are washer. That means here there is no washer, here there is a spring washer. That means when you just press here, when you just press here, then you will see it will act like a spring, and it will be tightened. And here there is, in between two plates, there is a soft material which is called gasket. Now due to the soft material, what happens? Due to the soft material, it will act as a leak proof. It will act as a leak proof. That means if on this side there is high pressure liquid, then for metal to metal contact, if there is metal to metal contact, then there may be some leakage. But if there is a gasket like thing, then there cannot be any leakage. So the gasket is used for that, and we will discuss something more over gasket. Now, now, now there is another thing, that is lock nut. Now, what is lock nut? Lock nut is like this. That means you see, lock nut means when there is vibration, then it won't be loosened when there is vibration. That means if you use only one nut, then there is a chance of loosening of the nut. Then what is happening? You see, there is a half size nut, and shape of the nut is like this, and there is another nut which is twice, thickness of this is twice of that. Then what is happening? How log nut is used? It is the smaller nut first tightened loosely. So smaller nut first tightened loosely, not tightly. Then this higher nut is used for exerting more force for tightening. So after tightening the higher diameter, higher thickness nut, you just you just call back the half nut. That means you turn it on the opposite side. So when the half nut is turned on the opposite side, then what will happening? The two nuts are tightly fitted over each other, and there would not be any loosening when there is vibration. And instead of half nut, sometimes two nuts of equal thickness are used. So this is one nut, this is another nut, and they are of equal thickness. The two equal thickness nuts are used for lock nut. So this is one type of lock nut. Is it clear? Is it clear to you? Hello?
হ্যাঁ স্যার, হ্যাঁ।
Okay, so this is one type of lock nut.
এইখানটা আচ্ছা লাস্ট লাইটটা লাস্ট পার্টও ডিলিট করবেন ওখানটা।
Last part দেখো, for this nut, this is the thickness is half of this. Here,
Huh.
here there are the two nuts of equal thickness, and diameter is 3/4 D and 3/4 D. Here diameter is D by 2 and D, but here diameter is 3/4 D and 3/4 D. That means instead of using a half nut and a full nut, we use two equal sizes of nuts of thickness 3.34 D. Okay, two equal sizes of nuts of thickness 3/4 D, and they are used as lock nuts. Is it clear? Okay. Some sound is coming from any one of your mind. Now, there are some more lock nut arrangements. One is like this. This is the nut, and there is a shock at here, and a cap screw. A small type of screw is used for tightening. That means when it is used, then if you use another screw here, then it will be tightened over the threaded surface. This is the arrangement. This is the arrangement. That means you use this set screw. There is another arrangement. You use this set screw. This is not like this. Here the axis of the cap screw is parallel to this, but here it is perpendicular to this. You see another threaded hole is there, and a set screw is inserted, and thread of this and the external thread of this is they mate each other. That means the locking is done at this point. Then another type of thing is tassel nut. Now for tassel nut, the arrangement is like this. That means there is a slot like this, and through this slot a split pin is used, and this split pin is used, and on both sides it is just bent on both sides. At the on the outside of the hole it is just bent, and it is called tassel nut. And while you use this split pin, then it will be tightly fitted over the bolt. So this is another type of lock nut arrangement. So lock nut arrangement, we have seen split nut, tassel nut, locking by pin, and locking by threaded pin, etc. Now the design considerations, these are very important. Now for designing screws, what are the stresses that are involved? That is very important. What are the stresses? Stresses in screw fastenings. What are the stresses? It is necessary, obviously it is necessary to determine what are the stresses while you are using the nut and bolt joint. Now for screws fastening, due to both static and dynamic load, so there is a condition of both static and dynamic load. So considering this static and dynamic load, we have to determine the dimension. Now for static load, we have to consider initial tightening and also external loadings. Both these should be known. Now what is initial tightening? That means you have to first tighten the bolt by using the nut. So there must be some initial tightening force. So there is initial tightening force, and there is some external load. That means, say two plates are there, and two plates are connected by a nut and bolt joint. Now what is happening? You have to first tighten the joint by using some initial tightening force. So the joint is made. Then this joint is subjected to some external load. So both these initial tightening and external load are to be considered for designing. Now the initial tightening load, what are the initial tightening load? This is very important. That means how the initial tightening load acts over that. Now say you just go to another figure. Sorry. Suppose you see the figure number 8. You see the figure number 8. Now there is initial tightening. That means the nut is nut is tightening. So there is initial tightening force. Now, while this initial tightening force is applied, then what will be the force over the bolt? Is it not tension? While you are applying initial tightening load, then bolt is subject to tensile load. Do you accept this? Hello.
Yes, sir.
Yes, sir.
So it is subjected to tensile force. Then while you are tightening the nut, what is happening? There is friction in between the outer in between the internal thread and external thread surfaces. So there is friction. So there will be frictional torque. And if these things are subjected to other type of loads, so it is first subjected to tensile stress due to the initial tightening. Then there will be torsional shear stress. That means due to frictional resistance, there will be torsional shear stress. Now, there will be shear stress across threads. Threads will be subjected to shear stress. Threads will be subjected to compressive stress. And if the bolt head is not exactly perpendicular to the surface of the plate, then there will be a bending stress. So these are the stresses which are induced due to the initial tightening load, whether you agree with me or not. That means first there is tensile stress, then there is torsional stress due to frictional resistance, then there is shear stress across threads, then there is compressive stress, and then if the axis, if the bolt head is not properly matching over the surface of the plate, then there will be a if they are not perfectly normal, then there will be bending stress. I will show you the diagram for the bending stress.
স্যার কম্প্রেসিভটা কোন জায়গাটা হচ্ছে একটু বলতে পারবেন?
Suppose one stress is one thread is pressing over another thread. That means one thread surface, say external thread surface, is pressing over the internal thread surface. So there is a compressive force. Okay?
Yes, sir. Yes, sir. Yes, sir.
And there will be shear stress also. Clear? So these
Yes,
are
sir.
the stresses. So many stresses are involved, and you cannot exactly find out the stresses. Here, you cannot find out the torsional shear stress. Torsional shear stress due to the friction. You cannot exactly find out the compressive stress. You cannot exactly find out the shear stress. So there is some empirical relation, and this empirical relation is coming from the experiments in different countries. So experiences throughout the world, there is experience, and from that experience it is taken that this pi, that means the empirical relation is pi should be equal to 2840 multiplied by d, where d is the nominal diameter of the bolt in millimeter. So 2840 multiplied by d Newton, that is the force which is due to the initial tension. So the design should be done on this pi when it is subjected to a dynamic stress, and when it needs that there should be leak proofing, there is no leakage, and when leak proofing arrangement is not required, then half of that, that means 1420 times of d Newton, that should be the pi. So when leak proofing arrangement is needed, you have to exert more force, and the pi should be 2840 times d, and when it is leak proofing is not needed, it is half of that, that is 1420 times of d, and these are from experimental experiences from in different countries. And due to this, what is the Ft? The normal stress Ft is equal to pi divided by pi by 4 d square. This is the core diameter. Now, since you see this DC, the stress is inversely proportional to the DC square. So if DC is very small, then there will be, the stress will be very high. So smaller diameters such as M16 may fail due to initial tightening. So if it is M16 or lower than that, the experience is it may fail due to initial tightening. And in such cases, torque range. Now, how the initial tightening is done? Initial tightening is given by a range, a torque range. A torque range is used for applying the load. Now, when the torque range is used, then MT is equal to, these are all empirical relation, C multiplied by Pi multiplied by D. So one factor is needed, and that is a constant depending on coefficient of friction at the making surfaces. So MT is equal to C multiplied by Pi D. So another C is needed. Here it is 2840 times D. Then another C is introduced, and that is a constant depending on coefficient of friction at the making surfaces. Now, the torsional shear stress. What will be the torsional shear stress? Torsional shear stress will be 16 MT divided by pi DC cube. This we know. Now, this is given by, the MT can be calculated considering the friction forces. This MT is calculated considering the friction forces. So MT is equal to Pi multiplied by dt by 2 into tan alpha plus phi. That means this phi comes from the frictional coefficient. Tan phi is equal to mu, and this alpha is your helix angle, lead angle. This alpha is the lead angle, and the MT is the equation for MT is this. So this is for the frictional torque. Now, when bolt is subjected to axial force and twisting moment due to tightening, so failure theory should be considered. So there is axial force and there is twisting moment. So we have to consider the failure equation, and equivalent stresses should be found out. That is F equivalent equal to Ft square plus 4 Fs square, and F equal, and these are from the two different type of failure theories. That means one due to maximum shear stress theory, and another due to maximum destruction energy theory. So first one is for maximum shear stress theory, and second one is for maximum destruction energy theory. So normally, considering tightening, friction and repeated screwing, that means while tightening there is friction, and repeated screwing, that means you are you have to unscrew the joint, or you have to screw the joint. That means there is repeated screwing. So due to repeated screwing, the value of C is equal to 1.322 or even 2.5. So this is the value of C. That is the factor for finding out Pi. Now ultimately, the expression for Ft is equal to Cpi divided by pi by 4 DC square, where C is equal to 1.5, 2 or 2.5. So these are the values. This is the equation for finding out Ft. Now, how bending stress comes? You see, I was telling that when the this surface of the bolt head and this surface of the plate, it is exaggerated form, shown in exaggerated form, and when they are not properly matching, so what will happen? You are giving the tightening force, and there will be bending, and the bending stress, the expression for bending stress, this is also one empirical relation. The expression for bending stress is this, that is Fb equal to x, x is this, look at the figure, this is x E by 12, where x is the difference between height between the extreme corners of the nut or head of bolt, and E is the modulus of elasticity of bolt material. So this is the expression for bending stresses. So when they are not perfectly matching, that means the lower surface of the bolt head and the upper surface of the plate, they are not perfectly matching, the bending stress arises. Now, how to find out the thickness of bolt head? That means the age. This is the bolt, and how to find out the thickness of bolt head? That means age is to be found out, and there is P. P is applied there. Now, thickness of bolt head H can be determined by considering bending, shear or compression. I have shown only bending. So you will be able to apply the shear equation and compression equation. Now the MB is equal to P multiplied by D by 2. That means this is P, and this is D. So and we are trying to find out this H. So due to bending, the bending moment is equal to MB equal to P multiplied by D by 2. And from that, bending stress equal to MB by Z, where Z is this. Z is pi d h square by 6. And from that, you can find out the expression for FB. Now, nut head thickness. So this is bolt head thickness. Nut head thickness can be found out from the strain condition of thread in shear, bending, and compression. So thread should be subjected to shear, subjected to bending, and subjected to compression. Now, strength in shear of threads. Now, for strength in shear, we know yield strength is in shear is half of yield strength in tension. That means this is a known equation. That means FYS, that means yield strength, is 0.5 tensile. Then you have to use one FOS, and ultimately Pi is equal to pi by 4 dc square Ft. Now Ft is equal to Fyt by FOS. FOS is factor of safety. So for bolt, Fs is equal to P by pi dch. H is equal to height of bolt head. So P is equal to pi dch Fys by Fs equal to pi dch Fy2 by 2 Fs. That means these equations are put. Ultimately, P is this. Now, from equations A and B, equating equations A and B for bolt and nut, equating equations A and B, we will get H equal to 0.5 dc. This we obtain, that means H is equal to 0.5 dc, and generally dc is 80% of D. That means 0.8 times 0.8, you multiply 0.8 here, then H will be equal to 0.4 D, because dc is equal to 80% of D. So this way we can find out H for bolt. Is it clear? Hello?
Yes, sir. Yes, sir.
Okay. Then we will find out, we will try to find out the thickness of the nut. Now for thickness of nut, Fs is equal to pi d Hn. This is shear stress. So pi d is the circumferential length multiplied by Hn. That is the thickness of nut. So Hn is the height of nut. If Z is the number of threads in engaged part, while engaged, some number of threads are engaged, and in that case, strength in crushing of threads, that means equal to pi by 4 d square minus dc square Fc into Z. That means Z number of threads are involved, and d square minus this pi by 4 d square minus dc square, that is the area. That is the area against crushing. So and multiplied by Fc. So this is speed. And from this Z, finding Z from this equation, we get Hn is equal to Z multiplied by P. Do you accept this? That means P is the pitch and Z is the number of threads engaged. So Hn will be equal to Z multiplied by P. Is it clear?
Yes, sir. Please continue.
Okay. Now bolts of uniform strength. Now what happens? You consider a bolt. So there is a shank and there is a threaded part, and you consider the threaded part. For the threaded part, there is a DC area. DC, that means core diameter area, core diameter part. So core diameter part is diameter is smaller. So diameter is smaller than the shank diameter. So the stress induced in the core diameter part is higher than the shank diameter part. So the requirement arises that the bolt should be of uniform strength. That means throughout the length, bolt should be of uniform strength. That means the shank should not be higher than the core diameter part. So bolt should be of uniform strength. So need is therefore to design bolts to absorb maximum impact energy and resist rupture in the threaded area. That means if the threaded area is of lower strength, then it is vulnerable to failure. So that is why in applications like connecting rod, mechanical presses, and power hammers, bolts are subjected to shock or impact loads. So need is therefore to design bolts to absorb maximum impact energy and resist rupture in threaded area. So for that, the unit resilience is the elastic energy stored up in a cubic meter of a material at the elastic state. This is the unit resilience, and that is given by Ep equal to F_Yp squared by 2m multiplied by V, where V is the volume. This expression is known to you. Now the cross-sectional area in threaded portion is minimum, and the stress in this portion of bolt is higher than shank. Since energy absorbed is proportional to the square of the stress at the same area, threaded area is more vulnerable to failure. Arrangement is done to relieve the threaded part from absorbing high energy. Here comes the concept of bolts of uniform strength. So the bolts of uniform strength comes from that concept. That means the thread area should not be allowed to absorb maximum impact energy, and that is why the bolts are made for uniform strength. Now there are two type of methods. Two methods used to achieve bolts of uniform strength are, that means reducing the shank diameter. So you reduce the shank diameter and equate it to that. You look at the figure. Look at the second figure. So look at the second figure. You see, this is the threaded area. This is the threaded area, and the core diameter is equal to the shank diameter. So when core diameter is equal to the shank diameter, then the entire bolt is of equal strength. Clear? And here the core diameter, here the shank diameter is not equal to the core diameter, but a hole is made in this way. A hole is made so that the area is equal, and the diameter of the hole is this. That means pi by 4 dh square equal to pi by 4 d square minus dc square, and from this the dh, that means hole diameter, is found out. So dh is equal to root over d square minus dc square. So this way, either you made a hole like this inside, or you make the shank diameter equal to the core diameter. Then the bolt will be of uniform strength. If there is any question. Hello.
Sir, the drill is done from the bolt head part.
Drill is done on the shank part.
From the bolt head part.
Otherwise, how will you make the drill? So there should be an end. You have to insert the drill. You have to insert the drill.
Yes, sir.
You cannot insert it from the right hand side. That means that from the threaded part. You have to do it from the head part, head end. Clear? Hello?
Sir, please continue.
Okay. So these are the concepts of bolt of uniform strength. Now another important thing will come across, that is eccentrically loaded bolted joints. That means whatever we have discussed so far, that is the load is in the direction of the axis of the bolt and nut. So it is not eccentric but is centric. That means along the axis. But if the load is such that it is not along the axis, suppose a bracket is there. You have shown, you have used, we use in household purpose brackets. Okay, you have used brackets in your home. Okay, so for suspending your shirts and clothes, we use bracket. And you just think of the shape of the bracket. The bolt is inserted into the wall, but the load is subjected not along the axis of the bolt, but it is perpendicular to the axis of the bolt. Do you think of my point? Can you think of the point? Hello.
Yes, sir.
So the load is eccentrically. So that is why it is called eccentrically loaded bolted joint. So brackets are bolted joint, but the load is eccentrically placed. Clear? Now there are different arrangements. There are different arrangements how the eccentric loads are placed. Now one arrangement is that forces on the plane of bolt, but the resultant is not passing to the center area. That means this is the figure. You look at this figure. You look at this figure. That means this is a bracket. This is your wall shape. This is your wall, and there is a bracket like thing like this. Now here is the load, and these are the bolts. That means here the load is in the plane of the bolt. Load is in the plane of the bolt. So location through forces on the plane of bolt, but the resultant is not passing to the center of area of bolt group. That means for this the resultant will not be passing to the center of the joint, to the center of the bolted joint. So location of the centroid of the now the analysis. So first is forces on the plane of bolt, but the resultant not passing to the center of area of bolt group. Now location of the analysis starts. Location of the centroid of the bolt array. Now this is say this is the location. A1, one bolt, A2, A3, A4, and A5. Say these are the bolts, and it has some center. It has some coordinate slides x1, y1, x2, y2, x3, y3, etc. in this plane x1. So the sectional areas are A1, A2, A3, A4, A5, etc. And the coordinates are x1, y1, x2, y2, etc. So the coordinates of G, that is the center of gravity of the group, are given by the center of gravity. So center of gravity, the coordinates of center of gravity is this. That means x bar is equal to a1x1 plus a2x2 plus dot 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 a5x5 divided by a1 plus a2 plus a3 plus a4 plus a5. That means sigma a1 ai xi divided by sigma ai. And this is the coordinates of x bar, this is x bar, and y bar is sigma ai yi divided by sigma ai. So x bar, y bar, that is the coordinates of centroid of bolt array is this. Now look at the figure. Now this arrangement can be expressed in the term, that means an eccentrically loaded bolted joint. The eccentric load is equivalent to a force. You just consider, this is very simple thing you have already studied. The eccentric load is equivalent to a force at the center G and the moment P multiplied by E. This is E. P multiplied by E about G. You accept this point? Yeah. So an eccentrically loaded arrangement is equivalent to a force at the center G and a moment E multiplied by E about G. The imaginary force P. So one imaginary force is introduced. The imaginary force P causes some shear stresses which are called primary shear stresses, and these shear stresses are P1 dash, P2 dash, P3 dash, P4 dash, P5 dash, etc. Here there are four. So P1 dash, P2 dash, P3 dash, P4 dash. Now P1 dash, P2 dash, P3 dash, P4 dash equal to P by number of bolts. Okay, so this is the primary shear force due to the application of this due to this P. So primary shear force. Now the moment PE about G results in secondary shear force like P1 dash 2, P2 dash 2, P3 dash 3, P4 dash 4. So at radial distances, so this is the arrangement. So there is primary shear forces and secondary shear forces. Now the secondary shear forces are at radial distances R1, R2, etc. So the equation will be E multiplied by E equal to P1 double dash into R1 plus P2 double dash into R2 plus P3 double dash into R3 plus P4 double dash into R4. So this is equal to P. So these are P2 double dash. This is the secondary shear force. P1 double dash, secondary shear force. P3 double dash, secondary shear force. P4 double dash, secondary shear force. So these are the secondary shear force, and the moment equation is this, that is P multiplied by E equal to P1 double dash R1, P2 double dash R2, P3 double dash R3 plus P4 double dash R4. And from this, it is assumed that the secondary shear force are proportional to the distances from the center of gravity. It is assumed. So P1 double dash equal to CR1, P2 double dash equal to CR2, P3 double dash equal to CR3, P4 double dash equal to CR4. And from this, P multiplied by E equal to C R1 square plus R3 square plus R3 square plus R4 square. That means C we can find out, that is P multiplied by E divided by R1 square plus R3 square plus R3 square plus R4 square. And therefore P1 double dash equal to this thing, P2 double dash equal to this thing, and P4 double dash, etc., this thing. So at each point there is a primary shear force and there is a secondary shear force, and this primary shear force and secondary shear force, that means at each point there is primary shear force and secondary, this is primary shear force, this is secondary shear force, and these two shear forces are acting at each point, and so we have to find out the resultant of these primary shear forces and secondary shear forces. So we will stop here today, and we will continue in the next day. That means how these primary shear forces, the resultant of primary shear forces and secondary shear forces are ultimately used for finding out the diameter of the bolts. Ultimately, we have to find out we are designing the bolt, we are designing this thing. That means ultimately we have to find out the diameter of the bolts for a particular eccentrically loaded bolted joint. So we will stop here today. Any question up to this?
Chalk.
Huh? Is it very tough? Huh?
স্যার এই হ্যাঁ এইখানটায় এই লাস্টে যে প্রাইমারি সেকেন্ডারি শিয়ার ফোর্সটা কোনটা মানে কোনটাকে বলছি মানে ওটাকে সেকেন্ডারি
শোনো
বলছি বুঝতে
শোনো
পারলাম না।
শোনো তুমি তো একটা ইমাজিনারি ফোর্স নিয়েছো, তাই তো?
Force,
একটা ইমাজিনারি তোমার একটা eccentrically there was an eccentrically load,
loaded,
eccentric load,
হুম
and that eccentric load is equivalent to a force at G and
হুম
a moment PE. This you accept, okay?
হ্যাঁ
So
হ্যাঁ
there are two effects. One is a force and another is a moment. Clear?
হুম হুম
So force has a role that will give an that will produce an shear force, and moment there is a P into E. So there must be a resisting moment for P into E. That means there will be a resisting moment. There is a P into E. You look at, there is a P into E. So there
হুম
must be some resisting moment, and these resisting moment will give rise to secondary shear forces. Primary shear forces due to the imaginary force at G. Okay, there was no force at G, but you have imagined a force at G, and this will give the primary. This gives rise to the primary shear force, and there is a moment.
হুম
Okay, this moment P multiplied E should be resisted by opposite moment, and that opposite due for
ও আচ্ছা
creating that opposite moment there must be some forces. These forces are secondary forces. Clear?
আচ্ছা
So
আচ্ছা মানে
at
ওটাকে
each
রেজিস্ট
point,
করা যাচ্ছে ও আচ্ছা আচ্ছা হুম
at
হুম
each point there is a primary shear force and there is a secondary shear force,
হুম হুম
because you have assumed this thing in this manner for the ease of your analysis. That means one force at the centroid and one moment. Is
হুম
it clear?
হুম
Okay. So we will end today here.